Problem solving with 3 sets. Example 3. The State Exams Commission sample paper, Junior Cert Higher Level. Question. A group of 100 students were surveyed to find whether they drank tea, coffee, or a soft drink at any time in the previous week. The data in the question supplied was 24 had not drunk any of the 3, 51 drank tea or coffee but not a soft drink, 41 drank tea, 20 drank at least 2 of the 3, 8 drank tea and a soft drink but not coffee, 4 drank all 3. Part A. Represent the above information on a Venn diagram. Part B. Find the probability that a student chosen at random from the group had drunk tea or coffee. And Part C. Find the probability that a student chosen at random from the group had drunk tea and coffee but not a soft drink. Now, key knowledge here is that when you're asked for A or B, that means A union B. The element can be from the set A or from the set B. If you're asked for A and B, that means A intersection B. We can only choose an element from set A that also happens to be in set B. Okay, so the first piece of information is that 4 drank all 3. So that's the intersection of all 3. That's where we begin all our questions. So that goes in the middle. Next bit of information, 9 drank a soft drink and coffee. So and means intersection. So D intersection C equals 9. So that means that the space left over here, let's just have a look. So the space left over then in the intersection will be 9, take away the 4 we already have, which is 5. Okay. The next piece of information then is that 8 drank tea and a soft drink but not coffee. So tea and a soft drink means intersection, okay, but not coffee, so we have to block out the coffee circle. So we're left with this little part here. And that's the little part there that is for the number 8. Okay. The next piece of information is that 20 drank at least 2 of the 3. Now this idea of at least 2 of the 3 comes up a lot in sets questions, and it always refers to this section of the graph. Okay, so if you think of this as a flower with 3 petals, the 3 petals are the areas where you have 2 options. So they each of those petals like 2 drinks. And then the center is where we like all 3 drinks. Okay? So it says at least 2 of the 3. So that means at least 2 and the 3. So that's all 4 parts of this diagram. Okay, so what we're told is that 20 drank at least 2 of the 3. So this section of the diagram represents 20 people. Now, if we look at our diagram, we've already accounted for 8, 4 and 5 people. So that means we can fill in this part here by taking those numbers away from 20. So the answer is 3. Okay. The next piece of information we have is that 41 drank tea. So we can fill in that 41 drank tea overall. And then this allows us to fill in who drank only tea, because we already know the 3, 4 and the 8. And if we take that away from 41, we get 26, which means 26 people drank tea only. Next piece of information was that 51 drank tea or coffee but not a soft drink. So or means union. So T union C, but not a soft drink. So take away or block out the circle for soft drinks. So this bit that's left, these 3 parts, the yellow, the green and the blue, all sum up to make the 51 people. Okay, so we'll be able to find this missing piece, the blue piece, by taking the 26 and the 3 away from 51. And that blue piece should represent the people that drink coffee only. They only drink coffee. So taking the 26 and the 3 away from 51, we have 22. So 22 people drink coffee only. Now that allows us now, as a consequence, we know all of the data for the blue circle, so we can add all of those up and find out what are the total number of people that drink coffee. So they add up to 34. Okay. The next piece of information then was that 24 had not drank any of the 3. Okay, so those 24 that didn't drink any of the 3 have to go out into this part outside the 3 circles within the universal set. Okay, now at this point we have all the data filled in except the people that drank soft drinks only right here. So we can now find this number by adding all of these numbers up together and taking it away from 100, which is the universal set number. So taking all of those away from 100, we're left with just 8 people unaccounted for. So they must be the 8 people that drink a soft drink only, and goes right here. And then finally, all our data is filled in, but what we could do now is just fill in how many people in total drink soft drinks. We'll just add these 4 numbers up together to find how many people drink soft drinks, and that is 25. Okay, so now that we've the Venn diagram filled in, we can answer the questions. Part B, find the probability that a student chosen at random from the group had drank tea or coffee. So or means union. So the probability of choosing a person from this section here, T union C. Now you can see there's a lot of people in this section, so we're going to have to add all of these people up. And to make a probability, we have to put it as a fraction out of the total number. Now the total number for this survey was 100. So adding these people all up then from T union C, we've 6 and 3 and 4 and 8 and 42 and 5 is 68. All over 100 to make my fraction. So there's my probability, 68 out of 100. You can write a probability as a fraction or as a decimal, 0.68, or change it into a percentage, 68% probability that if I choose one of these students from the 100, the likelihood is 68% that they drink tea or coffee. And then the last question, part C, find the probability that a student chosen at random from the group had drunk tea and coffee, but not a soft drink. So remember, and means intersection. So T intersection C, but not a soft drink. So here's T intersection C is the green, but not a soft drink means block out the D. So we're just left with this little part here, which we know are 3 students. So what's the probability of picking one of those 3 students? You have 3 chances out of 100. Write it as a fraction or as a decimal, 0.03, or as a percentage, 3%. Okay.